Okay, guys, in this video, we're gonna continue what we wanted to do with the previous example. Okay, just before going to the next example, I wanted to mention how you can actually annotate these models. To annotate the signals, okay, you go to the sidebar here, okay, and select annotation, okay. And when you select annotation, whenever you click anywhere in the on the on your model, then you can type. So for instance, this is my input, okay, this is input, okay, and basically this is I dot, or this is R, okay. So very simply, so this is basically again, you go to annotation, okay, this is I, okay, and this is ER, okay. So you can select different fonts. You can make these ones a little bit bigger, a little bit smaller, okay. And for instance, I'm gonna make it as dark red, okay. And the font, I would pick it as probably 14 to be a little bit more seen, okay. And then I will make it boldface, okay. And with this method, you can actually simply annotate these guys, okay. And you can move them around, or you can just add a little bit extra information to your model. For instance, if you bring an area here, okay, so you would say that this is the simulation results, or the simulations, for example, 20 that we solved in the class, okay. And you can make this one bigger, okay, and then you can just put the screenshots as well in the code for your reference, okay. Now, in the second part, what we're gonna do is we're gonna go and model this, okay, using the integrators, okay. And we showed you guys how we can actually make the block diagram, okay, for these guys, and then we want to bring that block diagram to the system. So let me just add a screenshot of this system, okay, to a new model, okay, and start working on that new model, okay. So again, I'm gonna go to Simulink, okay, and then I'll bring a new model here, a blank model, okay. And in this blank model, what I would like to do is I would like to use the integrators. I would like to use similar thing that we did in the class, okay. So look at this. Again, in this model, I have a junction here. I have a gain with the value of L, or 1 over L, okay. I have an integrator. I have a gain, okay, and this is going to be my output. Yes. So let's go ahead and bring the gains first. So you need two gains, one for 1 over L and one for R, okay. So just double click on this one. So two gains, okay. This is one gain, okay, and another here, one gain here, okay. And I'm just going to put them here and here. Yes. Okay. And also you need an integrator between the two of these guys. Yes. So I would need an integrator. Okay. And this is the integrator. I'm going to need them in between of two guys. Then you need the summer. Okay. So you just need a sum here. Okay. And this is going to give you the sum value. Okay. And probably at the end and at the beginning, you need a scope. Yes. So I just want to see what's going on in this system. Yes. So this is going to be my scope. Okay. And also just one scope to see probably the error or whatever that I want. Okay. So I'm going to have another scope here. Any arbitrary signal. You can look at this. Okay. Now you need to adjust the parameters of these blocks. Look, your junction gets En as the positive, and it's going to be subtracted by Ri. Okay. So this sum, if you guys look at this, let me just make this one a little bit bigger. This sum shows positive and positive. If you double click on this, okay, then you can have it as positive and negative. Okay. Now, if you apply this, you see that down here, the signal here is going to be negative right now. Yes. And you can have several signals, honestly, to this guy. Okay. So for instance, you can have 3, 4, or 5. You'll solve examples for those ones. Okay. So now the next gain, the first gain is basically 1 over L. So if you go ahead and put this one as 1 over L, okay, and click OK, this is going to be 1 over L, okay. This is the integral. This is another gain, which is going to be the value of R. This is your second gain, okay, and I just put this one as R, okay. Now let's connect the summer to the gain, to the integrator, to the gain again. So this is going to be connected to this one. This is going to be connected to this one. I'm just holding down the control and clicking on these blocks one after the other one. And this is in fact my input. Okay, so this is my scope, this is my output, sorry. So this is my EOUT, the voltage output, yes? So voltage output. So now you need a branch. If you look at this, you have a pickoff point here, you need a branch, and you need to take that branch back to the summer, to the junction, yes? So for getting that branch, you go to that signal, hold down or right click and left, just keep it down, okay, and then bring it back, okay, and then put it here, yeah, okay. So just make it a little bit nicer. This is going to be your value for the feedback, basically, okay, and at last you will have the input, yes, you'll have the input. Now, one thing that we didn't discuss is the integrator. If you click on the integrator, okay, you see that the integrator, you can apply some initial conditions. For instance, you can apply 0 initial condition for your value of I, or you can give it some other initial conditions. You can apply these initial conditions internally or from external source. Look at this. When it is from an external source, okay, then you will have another block which needs to give the value for the initial condition, okay. So let's go back and make it internally, okay, and then you can basically saturate the output of this integral, okay, and limit it. And there are some other options that we eventually going to use them, okay. But one thing that I wanted you guys to mention, to remember, is that you can name the value of this integral, okay. So for instance, you can name it as current, okay, and because this integral is in fact giving you the current, yes, okay. Now let's go ahead and just like the previous time, let's go and bring a source file here or a source to this block, okay. So I'm going to go to a sine function again, okay, as a source, okay. You see that sine wave here, this is the one that I would need, okay. And when you click on this one, okay, and connect it here, you see that you can somehow fix the values for this sine function, the amplitude, the bias, the frequency, okay. So you can change the frequency to, let's say, 3, okay. And also you can give it a phase angle, okay, let's say pi over 2, okay. And this is your sine function, okay. So this is just an input. You can bring any input that you like, okay. And at the end, if you want to look how your sine function looks like, okay, if you want to see how your sine function looks like, okay, so this is going to be your input file, okay. So this is going to be your input, okay. Now I think at this point we are ready to run this simulation, okay. So let's go ahead and run this. I'm going to go ahead and to simulations, and I'm going to press run button, yes, okay. It's going to compile the code. When the code runs, okay, it's going to be ready. So here, and you look at the output of the system. This is your output for 10 minutes to 10 seconds, okay, and this is going to be the input, yes, for 10 seconds as well. Now if you look at this output and input, let me just open this one a little bit more, okay. If you look at this output and input, you see that the scopes are not as smooth as you wanted. You see, there is jaggedness here, jaggedness here, jaggedness here, and also here. Okay, whereas the sine function, at least for the input, does not, normally it does not have these guys. So it has the initial value, it has the phase angle, okay. However, you see that there are a little bit of uh, jaggedness around the sine function, okay, which you want to basically eliminate those guys, and you want to have a smooth signal for your simulations. Okay. Now I'm going to show you guys how you can get that smooth signal, okay, from your simulation. So go to the modeling here and model setting. Yes, go to the modeling and model setting. When you click on model setting, it's going to bring you guys a window in which you can actually select the parameters of the numerical solver that Simulink is using to solve these ODEs. Okay, so in general, it has two types of solvers: the variable step and fixed steps. Okay, so most of the time we prefer fixed steps, specifically if you want to implement something. Okay, then from these fixed steps, you go and solve your basically select your solver. Okay, ODE1, which is the simplest one, is the Euler method. It's just use the Euler integration. The other one that's a little bit more stable is Ranch-Kutta. Let's click on Ranch-Kutta. Okay, and in this guy, in the solver details, let's go ahead and pick a sample time for this system. Let's say that I'm gonna pick 0.01 seconds as my sample time. Okay, so this is fixed. The solver does not change this one, and it's gonna use the Ranch-Kutta. Yes, so let's click apply. Okay, and run the model again. Okay, so this time around, when you run the model, okay, you see that the values of your signals are much better, much smoother. You see that? Okay, and this is the output value and this is the input value, okay, which are the values of your signals. Okay, so let's go to the next example. In the next example, we're gonna do the same thing for example 21 that we solved in the class.